All right, so here is the solutions to the second day of 2.1. In this one, we're going to see a little bit more practice with the fractions and the radicals, as well as some initial value problems. So, number 8, first thing I did is took the time to rewrite my fractions and my radicals. Notice that the 6 doesn't move. Remember, we only move the variables, we don't move the coefficients. And then I go through and do my antiderivative. Add 1 to the exponent, divide by the new exponent. Add 1 to the new exponent, add 1 to the exponent, divide by the new exponent. Here we would have ended up with negative 6 over 0, x to the 0 power, which is what's supposed to remind us that we've got the natural log, okay? And then again, add 1 to the new exponent, divide by the new exponent, add 1 to the exponent, divide by the new exponent. Don't forget about plus c. As we've discussed in class, for some people they don't really need to show this intermediate step, so if you went straight to your final answer, that would be fine. In that same vein, if you didn't include c in your intermediate step, it wouldn't matter, just make sure you have c in the final answer. So 13 is one of those cases where we have to split our problem up. Again, it is literally impossible to find the antiderivative without splitting these up. So I've split up my values. X squared over x would get me x. X to the 1/2 over x would get me x to the negative 1/2. And then 3 over x would get me 3x to the negative first. Again, we may be getting more comfortable with the idea that 3x to the negative first leads us to 3 times the natural log of the absolute value of x. And so if you didn't rewrite it in this form, knowing what its antiderivative already was, that'd be okay. And like we've seen before, add 1 to the exponent, divide by the new exponent, add 1 to the exponent, divide by the new exponent. If you don't show this intermediate step, that's fine. If you go straight to your final answer, that's great. And again, don't forget about plus c. If you don't write plus c until your final answer, that's okay. Just be very conscious of trying not to forget it. 14 is really kind of what we saw as our initial examples. We don't need to rewrite anything. We can simply go straight to our antiderivatives. And of course, don't forget about plus c. 18 again is one where we need to simplify before we can find our antiderivative. I know that I need to simplify because I've got a monomial in the denominator. So x squared over x gets me x. 4x over x gets me, negative 4x over x gets me negative 4. And again, the 7x to the negative first, you might already be recognizing as 7 natural log of the absolute value of x. So if you didn't write it in this form, that's okay. And so I add 1 to my exponents, divide by my new exponent, and of course, don't forget about plus c. 23 is an initial value problem, and I know that it's an initial value problem because they've given me a value for f. They've given me f prime. So I need to find my integral of f prime and then substitute in the given value so that I can solve. Again, if you skip this intermediate step as you find your antiderivative, that's okay. So if you went straight from your integral to your function, make sure you're labeling your function knowing that we have f of x is going to let us substitute in the 2 and the 0. So I substitute in 2 for my y value, 0 for my x value, end up with c equaling 2. And then as we discussed, make sure you take the time to rewrite your equation. The problem didn't ask you to solve for c, it asked you to find f of x. So make sure you give that final answer as f of x. 24, very similar. They've given me f prime, they've given me a value on f. I find my antiderivative, substitute in 0 for y, 1 for x. If you want to use your calculator to come up with this fraction, 37 over 12. If you use the decimal equivalent, that's okay. But again, knowing my c value, I take the time to go back and rewrite my function f of x. 26 is really no different than the last two. The only difference is we have to do the work twice because they give us acceleration, they give us information about velocity, and they give us information about position. So my integral of acceleration will get me velocity. Again, if you skip this intermediate step, that's okay. Then I use what I know from my velocity, that y is 1 when x is 1, solve for c, and so now I know what my velocity function is. I've still got to go back and do all this work one more time to get position. So I set up my integral of velocity, which is going to lead to position. Again, if you skip the intermediate step, that's fine. Now that I have my position function, I can substitute in 3 for y, 1 for x, solve for c, and then write my position function. So really it's no different than the last two problems, we just have to go through and do that work twice. All right, so that wraps up 2.1. We're going to continue seeing the anti-power rules. We move into 2.2. We're going to continue seeing problems where we're asked to solve for C. And yeah, that's about it. All right, so hope this helps. If it didn't, please ask questions in class, and I will see you soon.